Hi everyone, welcome to Winpoint online classes. In this session, we are going to discuss some of the important questions from the chapter Periodic Classification of Elements. Let's start the discussion. Important questions and answers. In the modern periodic table, which are the metals among the first 10 elements? We need to learn the name of first 10 elements. We need to write the names. Then we can find which all elements are metals in these 10 elements. These are the 10 elements. First element is hydrogen, second one is helium, third one is lithium, fourth one is beryllium, fifth one boron, sixth one carbon, seventh one nitrogen, eighth one oxygen, ninth one fluorine, 10th one neon. We need to find the metals among these 10 elements. Which all are metals here? Lithium is a metal, beryllium is a metal, so answer is lithium and beryllium. Lithium and beryllium are metals. Metals are present at the left side of the periodic table. Lithium and beryllium. By considering their position in the periodic table, which one of the following elements would you expect to have maximum metallic characteristics? For this question, we need to check the periodic table. So here you can see the periodic table. The elements are gallium, germanium, arsenic, selenium, beryllium. Which one is having more metallic character? That's the question. The metals will be at left side of the periodic table. Here, this side. Right? So which element is at the left side of the periodic table? That will be the answer. Here you can see that the beryllium is here. This is the position of beryllium. This element is at left side of the periodic table. So answer is beryllium. Position of beryllium is at left side of the periodic table. So it is having maximum metallic characteristics. Next question. Which of the following statements is not correct statement about the trends when going from left to right across the period of periodic table? Left to right across period. First point, the elements become less metallic in nature. That's true statement. When we are going from left to right, the elements are becoming less metallic. Means the non-metallic character is increasing. The number of valence electrons increases when we are going left to right. The valence electron, number of electrons in the outermost shell, it is increasing. That's a true statement. Atoms lose their electrons more easily. That's a wrong statement. When we are going left to right, the nucleus of atoms are getting more power. The nucleus are becoming powerful. Because of that, we can say that this statement is wrong. The oxides become more acidic when we are going from left to right. The oxides are becoming more acidic. That's true, because on the right side is non-metals. Non-metallic oxides are acidic. The answer is the atoms lose their electrons more easily. This is a wrong statement. Next question. Elements X forms a chloride with the formula of XCl2, which is a solid with a high melting point. X would be most likely to be in the same group of periodic table as sodium, magnesium, aluminium, silicon. XCl2 is a compound, right? Do you know how we can write the chemical formula? We need to find the valency, and after that we need to interchange the valency. If you don't know to find the chemical formula, you can click on the link above, then you can learn it. Here the formula of the compound is XCl2. Valency of X will be 2 and valency of chlorine will be 1. That's why we are interchanging that and we are getting XCl2, X1Cl2. Valency of chlorine is 1, valency of X is 2. So we know the valency now. Now we need to find the valencies of these elements Na, Mg, Al, Si. For that we need to write the electronic configuration. Sodium 11. What will be the electronic configuration? 281. The valency 1, right? Next one, magnesium. What is the atomic number? 12. 12 is the atomic number. The electronic configuration is 282. The valency 2. Next element, aluminium 13. Configuration is 283. The valency 3. Silicon 14. 284. The valency 4. Magnesium and the X element is having same valency. Mg, the valency is 2. The valency of X is also 2. So we can conclude that element X will be in the group of magnesium. Magnesium and X both are in same group because the valencies are same. Answer is magnesium. Which element has two shells, both of which are completely filled with electrons? Question B. The electron configuration 282. A total 3 shells with 4 electrons in its valence shell. D. A total of 2 shells with 3 electrons in its valence shell. Twice as many electrons in its first shell as in its first shell. Which element has 2 shells, both of which are completely filled with electrons? 2 shells. And these 2 shells are completely filled with electrons. What will be the configuration? K shell, L shell. These two shells are completely filled with electrons. K shell 2, L shell 8. Now it is completely filled with electrons. Can you identify the elements? 2 plus 8, 10. Atomic number is 10. Element is neon. Element is neon. Next one. The electronic configuration 282. If we know the electronic configuration, we can find the atomic number. It is the shell KLM and 282. If we know the electronic configuration, we can find the atomic number. It will be 2 plus 8 plus 2, right? So we can write 2 plus 8 plus 2. Atomic number 12. The element is magnesium. Next one. Which element has a total of 3 shells with 4 electrons in its valence shell? There are 3 shells. So K, L, M. There are 3 shells. Outermost shell is having 4 electrons, right? So we can write 2, 8, 4. Can you identify the element? 2 plus 8 plus 4 equal to 14. Silicon. Element is silicon. Next one. Total of 2 shells with 3 electrons in its valence shell. There are 2 shells. K, L, and the valence electron, the number of electron in the outermost shell is 3. The number of electrons in L should be 3, right? So 2, 3. The element is boron. 2 plus 3, 5. Atomic number is 5, which means the element is boron. Next one. Which element has twice as many electrons in its second shell as in its first shell? First shell, if the first shell is having 2, second shell should be having 4. Twice, right? KL. First shell is having 2 electron, then second shell should have 4 electrons. 4, 2, 4. The atomic number will be 2 plus 4 is equal to 6. Element is carbon. What property do all elements in the same column of the periodic table as boron have in common? What property do all elements in the same column of the periodic table as fluorine have in common? This question is related to properties, so we need to find the group number. Let's do that. First one. What property do all elements in the same column of periodic table as boron have in common? We know that the element is boron and we can find the group number of boron. What other elements are having like boron? That's the question. First we are finding the group number. Boron atomic number 5. The configuration will be 2, 3. The valence electron, number of electrons in the valence shell, it is 3. Valency will be 3. Boron, the valency of boron is 3. Number of valence electron is 3. The group number is 13, right? The group number is 13. Then we can say that all elements in group 13 are going to have same number of valence electron. All the elements of that column are having same valence electron and same valency because it is a group. If the boron is having 3 electrons in the valence shell, all other elements are having 3 electrons in the valence shell. Next question is related to fluorine. The same question. Fluorine is member of a group. First we are finding the valence electron. The elements which are present in the same group of fluorine will be having same number of valence electron and same valency. We can write the electronic configuration. KL, these are the shell. The electronic configuration will be 2, 7, 2, 7. What will be the number of electrons in the outermost shell? Number of electron is 7. What will be the valency? There are 7 electrons in the outermost shell. To complete the octet, there is a requirement of 1 electron. So the valency is 1. All the elements of that column are having same valence electron and same valency. All the elements of group 17. Fluorine is in group 17. All the elements of that group 17 are going to have the same number of valence electron and same valency.